Good morning, everyone. Welcome again to my YouTube channel. Today I'll be talking about we'll be just doing some practical problems regarding integrals. If you remember from the previous video, I did explain the concept of integrals that we discussed, that it was the area under the curve. So today I'll be taking this opportunity to do more practice problems together, and also to cover a little bit some concepts that I may have missed in the previous video. All right, let's get started. This one thing maybe I thought it would be important is to understand, if I'm given a constant, how will I take the integral of it? So if I'm asked to find the integral of k dx, where k is a constant. So this integral will just be equals to k plus a constant. Okay, so it will be kx plus a constant. Okay, so let's say I'm given 8 dx as my function. I'm asked to evaluate the integral of this one. This will be just 8x plus a constant. Now, if you're wondering why is it 8x, you can think of it as a constant is the same thing as saying x to the 0, right? So this is the same thing as 8x to the 0, because x to the 0 equals to 1. So dx. Now, if we apply the same concept of where we added 1, so we said in the previous video that x to the power n dx, the integral of it is x to the power n plus 1 divided by n plus 1 plus a constant. Now, in this case, n is 0, so it will be 8x. So what's n? So we said 0 plus 1 divided by n, which is 0 plus 1 plus a constant. Now, this will give me, so I'm just going to go ahead and erase this thing right here. All right, so this will give me 8x to the power 1 divided by 1 plus a constant. So this is equals to 8x plus a constant, and that's why we get this. So whenever you are given a constant, just remember that you just have to add the x to it. Okay, so now moving on, what is the integral of, you may see these as well, right? E to the x dx. The integral of e to the x dx is just equals to e to the x plus c being the constant. Because remember, if you derive the integral, you should get the original function, right? So just like if I derive this function 8x plus c, I will get 8, because the derivative of 8x is 8, and the derivative of a constant is 0. The same thing here, if I derive e to the x, I will just get e to the x, which will be the original function. Now, what happens if I'm given, I'm asked to evaluate integral of 4e to the x dx? Well, what I do is I'll just take out the 4 because it's a constant. So 4 times times the integral of e to the x dx, and we just said that the integral of e to the x dx is just equals to ex plus a constant. So this will just give me 4 e to the x plus a constant. I hope this makes sense. Now, one more concept. So let's say I'm asked to evaluate 1 to the x dx. If you are asked to evaluate the integral of 1 over x dx, this equals to ln of x plus a constant. Same thing. So it really doesn't matter if I'm given 8 over x dx. I'm asked to evaluate the integral of this. It would be just 8 ln of x plus a constant. Okay, I hope this makes sense, and if it doesn't, I will highly encourage you to go back to the videos and watch it as many times as you want until hopefully it clicks, right? I will do little more examples. Okay, let me erase this. All right, so let's say I'm given integral of 3x to the power 5 plus 7x squared plus 8 dx. I'm asked to evaluate this integral. So what I will do is I will take the first integral, add the second integral, add the integral of the third term, right? Now, what is the integral of 3x to the power 5? So 3 is a constant. So this is what I will do. 3 times x to the power 5. This is the same rule as we said earlier, that the integral of x to the n dx equals to x n plus 1 over n plus 1, plus a constant, okay? Now, what is my n? N is 5, so it's n plus 1 divided by n is 5, so n plus 1, okay? I don't need to add the constant now, I can add it at the very end, because a constant plus a constant is just a constant. I can just call everything a constant at the very end. So I will not worry about that for now. And now I add plus 7 times, what is the integral of x squared? So it's x 2 plus 1 divided by 2 plus 1, right? N plus 1 over n plus 1. Plus 8. Now we said the integral of a constant, right, is just the constant times x. So 8x. Now plus the big constant c. Sorry, I'm running out of space here, but this is a c. I will go ahead and rewrite it here. So 3x to the power 5 plus 1 is 6 divided by 6 plus 7x cubed over 3, 2 plus 1, plus 8x plus a constant. Again, this is just a general constant, right, of all the constants. Now, what will this, I can simplify this. 3 divided by 6 is 1/2 x power 6, okay, plus 7/3 x cubed plus 8x plus c. And this will be it as our integral. Now, in order to verify, because an integral is an antiderivative, so that means if I derive this function, I should get back this original one. Let's go ahead and verify that, okay? So what is the derivative of this? So now I'm evaluating the derivative of this function. So I will call this one big f of x, and then I will go ahead and call this my big f prime of x. What will this be? So 1/2 our derivative, so power down, power minus 1, so 6 minus 1 over, okay, 6, power down x 6 minus 1 plus 7/3 times the power, which is 3, x 3 minus 1 is 2, plus 8x, because x to the power 1 minus 1 is 0, so it's going to give us x to the 0, which is 1, so it's just going to give me 8. What's the derivative of a constant? 0, so plus 0 here, okay? Let's go ahead and simplify. So my big f prime of x equals, so what is this? 6 divided by 2 is 3, x 6 minus 1 is 5, plus 3 and 3 cancel out, so I'm left with 7x squared plus 8 plus 0. So now this will give me, so f prime of x equals to the original function, just like we expected it. I hope this makes sense. All right, so I will go ahead and do another example. You don't always, by the way, you don't always have to verify this, but it's a good practice to verify, just to make sure you didn't make any mistake in your integral. I guess, I mean, some problems, depending on your teacher, you may be asked to just find the derivative of the integral, just to make sure you actually got it right. All right, one more. Let me do another example here. So I have the integral of 4 plus 3x plus 2 to the x to the power 4 divided dx, okay? So the best way to do this is to try to simplify this expression, so that way at least I don't have to deal with the x at the bottom, right? So what can I do? So I can just rewrite this as 4 over x plus 3x over x plus 2x to the power 4 over x dx. Now, these are kind of a little bit easier to integrate, right? Now, if you remember a few minutes ago, I said that the integral of 1 over x is just what? ln of x. So the 4 is just a constant, so so the integral of 4 over x is 4 ln of x, okay? Plus, what is the integral of this one? So these x's will cancel out here. This is before even I take the integral. So the integral of 3 dx, since it's a constant, it will be just 3x plus, now this can be simplified to x cubed, right? So I can just rewrite this as 2 to the x cubed. What would that be? So that's 2, that is applying the power rule here. So x 3 plus 1 over 3 plus 1. Of course, plus a constant. You will know that this is very important to keep the constant in there, because in some problems you may be asked to evaluate what this constant will be, and that's what I will cover in the next video. Alright, so this will be 4 ln x plus 3x plus, now what will this be? So this is 2 over 4 x to the power 4, okay, plus constant. Let's simplify this further. 4 ln x plus 3x plus 1/2 x to the power 4 plus a constant. And this will be it for our integral. Now for your practice, I would want you to go ahead and take the derivative of this function and see if you will get back the same thing as the original function. I hope this makes sense. Like I said, in the next video, I will cover how to evaluate this constant if you're given a function and 1 point on the function. Thank you for watching, and please share and like this video, and have a great day. Thank you.